According to the National Electrical Code, pool motors must be protected by ground fault circuit interrupters, or GFCIs. GFCIs are designed to trip the circuit if an electrical current leak is detected. This helps to prevent electrical shock or electrocution. The NEC requires all swimming pools, spas, and hot tubs to have GFCI protection for all electrical outlets, switches, and equipment within 6 feet of the water's edge. This includes pool motors, pumps, and other electrical devices. The NEC also mandates that pool motors be installed at least 5 feet away from the inside wall of the pool. This precaution helps prevent electrocution should someone accidentally touch the motor while in the pool. If pool motors are located less than 6 feet from the inside wall of the pool, they must be protected by GFCIs. If the current service panel lacks GFCI breakers for the pool motors, a qualified electrician is needed to install them. GFCIs work by monitoring the current flowing into and out of a circuit. If there is a difference of more than a few milliamps, the GFCI trips the circuit, cutting off the power. This happens very quickly, typically within a fraction of a second, which is fast enough to prevent serious injury. There are 2 main types of GFCIs available. Firstly, GFCI breakers. These are installed in the service panel and protect the entire circuit. Secondly, GFCI receptacles. These are installed in place of standard electrical outlets and only protect devices plugged into that specific outlet. For pool motors, GFCI breakers are generally recommended as they provide protection for the entire motor circuit, including the wiring and any other devices connected to it. When selecting a GFCI breaker for a pool motor, it is important to choose one that is rated for the specific motor. The motor's nameplate will indicate its voltage, amperage, and horsepower. This information is crucial for selecting the correct GFCI breaker. It is also important to ensure that the GFCI breaker is properly installed and wired according to the manufacturer's instructions and local electrical codes. Incorrect installation can render the GFCI ineffective or even create a safety hazard. Regular testing of GFCIs is essential to ensure they are functioning correctly. The NEC recommends testing GFCIs monthly using the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to GFCI protection, there are other safety measures that should be taken around swimming pools to prevent electrical hazards. These include keeping electrical cords and devices away from the water, never using electrical appliances while in a pool, and having a qualified electrician inspect the pool's electrical system regularly. Bonding is another crucial aspect of pool electrical safety. Bonding involves connecting all metal parts of the pool, including the pool structure, metal fittings, pump motor, and any other metal equipment to a common grounding system. This helps to equalize the electrical potential between these parts, reducing the risk of electric shock. The NEC specifies detailed requirements for pool bonding, including the size and type of bonding conductors, and the methods for connecting them. It is important to follow these requirements carefully to ensure a safe and effective bonding system. Furthermore, equipotential bonding is required in specific locations around the pool. Equipotential bonding aims to create an area of equal electrical potential around the pool, minimizing voltage differences that could cause shock hazards. This is typically achieved by installing a grid of conductive material, such as copper wire, under the pool deck and bonding it to the pool's grounding system. The NEC provides specific guidelines for equipotential bonding, including the area to be covered and the methods for connecting the bonding grid. Submersible pool lights also require careful attention to safety. These lights are designed to operate underwater and must be specifically listed for that purpose. They should be installed in accordance with the manufacturer's instructions and the NEC requirements. Typically, submersible pool lights operate at a low voltage, such as 12 volts, to reduce the risk of electric shock. A transformer is used to step down the voltage from the standard 120 volts or 240 volts to the low voltage required by the lights. The transformer should be located in a dry, protected area away from the pool. Wiring for pool equipment should be installed in conduit, which is a protective tubing that encases the wires. Conduit helps to protect the wires from physical damage and moisture, reducing the risk of electrical faults. The NEC specifies the types of conduit that are permitted for use in different locations around the pole. Underground wiring should be buried at a sufficient depth to prevent damage from digging or other activities. The depth requirements vary depending on the type of wiring and the location. Regular inspections of pool electrical systems are essential for identifying and correcting potential hazards. These inspections should be performed by a qualified electrician who is familiar with the NEC requirements for swimming pools. The electrician should inspect all electrical equipment, wiring, bonding connections, and GFCIs to ensure they are in good working condition and comply with the code. Any deficiencies should be corrected promptly to maintain a safe swimming environment. In addition to the NEC, local electrical codes may also have specific requirements for swimming pool electrical systems. It is important to check with the local building department or electrical inspector to determine the applicable codes and regulations. These codes may address issues such as the placement of electrical outlets, the type of wiring allowed, and the requirements for bonding and grounding. Adhering to both the NEC and local codes is essential for ensuring a safe and compliant pool electrical system. When working on pool electrical systems, it is crucial to follow safe work practices. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical systems in wet conditions. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician to do the job. In summary, GFCI protection is a critical safety requirement for pool motors and other electrical equipment around swimming pools. The NEC mandates GFCI protection for all electrical outlets, switches, and equipment within 6 feet of the water's edge. Pool motors should also be installed at least 5 feet away from the inside wall of the pool. Regular testing of GFCIs, proper bonding and grounding, and adherence to safe work practices are essential for preventing electrical hazards around swimming pools. Consulting with a qualified electrician and following the NEC and local electrical codes will help ensure a safe and enjoyable swimming experience. Consider that a ground fault is an unintentional electrical path between a source of current and ground. This can occur when insulation fails, or when water comes into contact with electrical components. Because water is a conductor of electricity, the presence of water around a pool significantly increases the risk of ground faults. A GFCI works by monitoring the balance of current in the hot and neutral wires of a circuit. Under normal circumstances, the current flowing through these wires should be equal. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance. The GFCI detects this imbalance and quickly trips the circuit, cutting off the power. The tripping time of a GFCI is typically very fast, on the order of milliseconds, which is fast enough to prevent serious injury or death. The sensitivity of a GFCI is typically 5 milliamps, meaning that it will trip if it detects a current imbalance of 5 milliamps or more. This level of sensitivity is sufficient to protect against electric shock, while minimizing nuisance tripping due to minor leakage currents. GFCI protection is required not only for pool motors but also for other electrical equipment around the pool, such as lighting, pumps, and heaters. Any electrical outlet within 20 feet of the pool's edge must also be GFCI protected. This requirement is intended to prevent people from using electrical appliances near the pool, which could create a shock hazard. In addition to GFCI protection, swimming pools must also be properly bonded and grounded. Bonding involves connecting all metal parts of the pool, such as the pool structure, metal railings, and metal equipment, to a common grounding system. This helps to equalize the electrical potential between these parts, reducing the risk of electric shock. Grounding involves connecting the pool's grounding system to the earth, providing a path for fault current to flow back to the source in the event of a ground fault. The NEC provides detailed requirements for bonding and grounding swimming pools, and it is important to follow these requirements carefully to ensure a safe installation. Regular inspections of swimming pool electrical systems are essential for identifying and correcting potential hazards. These inspections should be performed by a qualified electrician who is familiar with the NEC requirements for swimming pools. The electrician should inspect all electrical equipment, wiring, bonding connections, and GFCIs to ensure they are in good working condition and comply with the code. Any deficiencies should be corrected promptly to maintain a safe swimming environment. It is also important to educate pool users about electrical safety. Pool users should be warned not to use electrical appliances near the pool and to avoid touching electrical equipment while in the pool. They should also be instructed to report any electrical hazards to the pool operator or owner. By following these safety precautions, it is possible to minimize the risk of electrical accidents around swimming pools. Firstly, ensure all electrical work is performed by a qualified electrician who is familiar with the NEC requirements for swimming pools. Secondly, install GFCI protection for all electrical outlets, switches, and equipment within 20 feet of the pool's edge. Thirdly, bond and ground the pool in accordance with the NEC requirements. Fourthly, inspect the pool's electrical system regularly and correct any deficiencies promptly. Fifthly, educate pool users about electrical safety. By following these steps, it is possible to create a safe and enjoyable swimming environment for everyone. The NEC is updated every 3 years, and it is important to stay up to date with the latest requirements. Changes to the NEC can affect the design and installation of swimming pool electrical systems, and it is important to comply with the latest code to ensure safety. The local building department or electrical inspector can provide information on the latest NEC requirements for swimming pools in your area. It is also important to follow the manufacturer's instructions for installing and maintaining swimming pool electrical equipment. The manufacturer's instructions provide detailed information on the proper installation and operation of the equipment, and it is important to follow these instructions carefully to ensure safe and reliable performance. In addition to the NEC and the manufacturer's instructions, it is also important to consider any local codes or regulations that may apply to swimming pool electrical systems. Local codes may have additional requirements that are not covered by the NEC, and it is important to comply with these codes to ensure a safe and compliant installation. It is a must to consult with the local building department or electrical inspector to determine the applicable codes and regulations for your area. GFCI receptacles and GFCI circuit breakers both offer ground fault protection, but they do so in different ways. A GFCI receptacle is installed in place of a standard electrical outlet and protects only the devices plugged into the receptacle. A GFCI circuit breaker is installed in the service panel and protects the entire circuit, including all outlets and devices connected to that circuit. For swimming pools, GFCI circuit breakers are generally recommended because they provide protection for the entire pool circuit, including the pump motor, lighting, and any other electrical equipment. This provides a higher level of safety than GFCI receptacles, which only protect the devices plugged into them. When selecting a GFCI circuit breaker for a swimming pool, it is important to choose one that is rated for the specific application. The circuit breaker should be sized to match the ampacity of the circuit and should be rated for use in wet locations. It is also important to choose a circuit breaker that is listed by a recognized testing laboratory such as Underwriters Laboratories to ensure that it meets safety standards. Regular testing of GFCI circuit breakers is essential to ensure that they are functioning properly. The NEC recommends testing GFCI circuit breakers monthly by pressing the test button on the circuit breaker. If the circuit breaker does not trip when the test button is pressed, it should be replaced immediately. In addition to GFCI protection, swimming pools should also be equipped with a safety switch that allows the power to the pool equipment to be quickly shut off in an emergency. The safety switch should be located in a readily accessible location, such as near the pool entrance. The safety switch should be clearly labeled and should be easy to operate. Pool owners and operators should be trained on how to use the safety switch in case of an emergency. Swimming pool electrical systems are complex and potentially dangerous. It is important to take all necessary precautions to ensure the safety of pool users. By following the NEC requirements, local codes, and manufacturer's instructions, and by implementing safe work practices, it is possible to minimize the risk of electrical accidents around swimming pools. Pool motors that are 20 feet away from the inside wall of the pool may not be in accordance to NEC requirement of at least 5 feet away from the inside wall of the pool. The distance may have been mistakenly measured.